Let's see together how our scheme looks, how to read our schematic diagram. All right, great. You have to remember that to read the schematic diagram, there are some keywords you need to know. These are key terms for the drawing so you can understand your drawing. So what are these keys? They are about the drawing, type, drawing details, drawing number, the type of feeder you have, the number of pages you have, the details present on each page, something we call cross-reference, which is the drawing read. We'll see it together. Who is the manufacturer? Who is the end client? Okay, come on, Engineer Rashad. Of course, I'm not going to memorize them in my head. You don't memorize them. Here we start to see how the matter is. If you look here, engineer, come one by one. I'm telling you, this page is the first page in the drawing. I send it to you via a link or the Dropbox link. I sent you this drawing, all right? So I have this drawing, the first page in front of me. So what will I benefit from this page? What should I understand from it? Let's see together. This page contains some keys or keywords. If I tell you now to use them in the same other pages, the first thing you have here is the place where you write the manufacturer. As you can see, the word manufacturer or vendor name. Who is the manufacturer, the factory, or who is the vendor name? Who is the vendor? That gave you this cell. So, of course, you have here this cell, or the drawing we are working on is the drawing of Alphanar Company, or the switchgear of Alphanar Company. Next, we come here to who your end client is. And it is written here, as you can see, the Saudi Electricity Transmission Company. Nice, great. Then it writes here something called drawing type. What is the type of this drawing? So you have several types available. You have stage, which is the pre-stage, like a phase in the stations when you are conducting tests. Naturally, you might find errors. It's normal to find them during this stage. When the young workers come to us, they might find that first, you need to ensure that everything drawn matches the cell in front of you or not. So it's very natural to find some slightly different things due to the designer sending you an old file he has, meaning there might be some errors in the text. Very nice. The second thing is that this factory produces this cell for Alphanar, for example, or sends it to the Saudi Electricity Company, or sends it to the Marab factory, sends it here, sends it there. So the Saudi Electricity Company might have a specific standard with certain requirements, while another place has different requirements. The person receiving the work from you or a consultant might come and say, no, I want you to add this part, do this part. So you start making modifications to your drawing. After that, these modifications are made to our drawing. And we move to the next stage, the commissioning stage. They might tell you this drawing is at the commissioning stage or refer to the markup. The markup is where you've erased things in green and drawn things in red, meaning you've removed some things, added others, and made modifications. This is what is meant by the markup drawing. And then you take this markup, give it back to the designer, and the designer starts drawing it on whatever tool they are using and returns it to you ready with the modifications drawn in. This is what we call, it's like the panel built in front of them, where all the drawings have been implemented on the cell itself. This is what we call the buzz, the buzz, the buzz, the buzz, the buzz. Beautiful, guys, very nice. Okay, let's move on to the details of the drawing here. It says the first thing is the optimized scheme diagram for capacitor bank 801. Firstly, the optimized scheme diagram is a result of the Saudi Electricity Company starting to create a fixed optimized scheme for all its stations with all its requirements. So you get something called an optimized scheme. Okay, and this is the listing for the capacitor bank feeder. And your cell number is H01. Each cell has a number. If you come here to the single line diagram, I didn't want to throw it at you now. I said, let's leave it for later. Here you will find H05, H06, and so on. There's a number for each cell, which is natural. So I know which cell I am talking about. Okay, and here is the type of feeder or the voltage of this feeder, which is 13.8. It's a capacitor bank feeder. All right, great. The name of the station is Construction of New Al Mubarakiyah, a construction station in Al Mubarakiyah. The station voltage is 132 to 13.8 kV SS, which stands for substation. All right, then 10 kV SS, which is what exactly? Okay, All right, engineer. So what data do you have here? Then we come down here to something called the drawing number. Here, this drawing number, engineer, is for each drawing file you have with its bar number, so that later on, when we come to see that you have showing interlocking and interface or interaction between the cells and each other, with the presence of things like interlocking, for example, between the bus bar, air switch, and the other feeders, between the circuit breaker of the other feeders and the bus bar air switch, and so on. So these are cells that have interwiring and or wires connected between them. So always in the drawing, it tells you this belongs to a certain drawing, and it writes the drawing number or a description of what it means, like it tells you the cell number, its name, and its drawing number. So when you go to your library, if you have a cabinet in the station or you have it on the software, you look for the cabinet in the station. It is written on the side of the drawing, like there is a file, of course, and the file has the cell number and the drawing number written on the side. You make sure it is the correct one and pull the drawing that you are working with here, okay? And then here below, it tells you the number, meaning 1. So this is 32 sheets or 32 pages, and you have this as page number 1. Its number was something like 0, 0, 0, 1, 0, 2, 0, 3. This means the drawing has been revised and updated several times. You start making modifications, apply them, make modifications, apply them, and make modifications, apply them. So it shows you what is available to you. All right, so you can reach the latest revision and ensure it is the latest revision. Great, and once you see it, that's really good. Then comes something very critical that we always use when reading our drawing. This drawing has something we call, all right, it has something we call our own. What does our own mean? As you can see here, you have a set of rows with letters and a set of columns with numbers 1, 2, 3, 4, 5, and so on. So when you're inside the drawing and it's drawing things, or it comes to tell you that this contact is specific to the axle located in the place called A2, do you understand where A2 is? Because it will tell you on page 30, A2. So of course, when you're on page 30, you'll find many things drawn. Which one of them is A2? It means you follow the initial number or letter or the initial symbol, which is usually a letter, which is the row letter or the column letter. Your row letter is A, B, or C. And the second number or the second symbol or the second field contains the column number. So it means that the thing I'm referring to is located at the intersection between the row named and the column named 2. Therefore, when you go to the drawing and find many things drawn, don't bother with them. Go directly to the section he mentioned and you'll find the contact you need. This information is also very important for the people working in the field because you are a person working in troubleshooting, a person. It's not necessarily that you have memorized this drawing, nor is it necessary that you have worked on it before. You might have worked in one factory and then moved to another and so on. All right, good. Let's move on to the next page, which in my opinion is one of the most important pages we have. So whose page is this? It's a page called, here we will add something to ourselves. What is the thing you will add for us, Mr. Rashad? You, Mr. Rashad, in this page, there is something that wasn't written and it will start appearing on the second page. It was written in front of you, but you might not have paid much attention to it. Look, sir, down here it says what? It says list of what? List of pages, and below it 13.8.10 capacitor bank feeder construction of Al Mubaraka. We saw the same view here. 13.8 construction, but before it was written, optimized scheme diagram capacitor bank H01. So what was written here is a description of this page, indicating that this page describes the optimized scheme diagram for the capacitor bank feeder of cell number H01. The cell number is H01. However, this page tells you that it contains information in the list of pages. What does list of pages mean? As you can see here, these are the pages you have. For example, it tells you the first page is the optimized scheme diagram capacitor bank H01. It described the first page for you, The second page is the list of pages you are on. The third page is the bill of materials. The fourth page is something else. The fifth page is something else. So how will this help me? It will help me if I now enter a Schneider station. I've been working with Siemens all my life, and I enter a station, let's say not a Schneider station, but an artist station. So what is it, engineer? I came to the operations guy and asked him what problem he had. He told me, well, the breaker isn't closing. Okay, the breaker isn't closing. Yes, then there is a problem in the control circuit of the circuit breaker. Closing, okay, fine. Where do I open the SCADA? This is a strange and unfamiliar drawing to me. Keep in mind, I might be talking about 32 pages in ABB, for example. The 380 kV might have 171 pages. Yes, the one that has the drawing relevant to you and the one that isn't relevant to you, a full 370 pages. So if you take from the first 170, those are the ones relevant to you. Anyway, what I do is come here to this list of pages and look for something related to the circuit breaker. Yes, the VCB closing circuit. Here, the circuit breaker closing circuit, the closing mechanism for the circuit breaker. And as for AVD, I'll tell you about it. It's what we call the vacuum circuit breaker. I'll explain it to you when we come to connect it to the circuit breaker. All right, not forgetting. Very good. Okay, so here, you can use it to go to the page you want for a specific function. Like, for example, the closing circuit for the circuit breaker. So you go directly to page 15 instead of flipping through without knowing which page you're on or what you're doing. This page contains something called the bill of materials. What does the bill of materials mean? This bill of materials, engineer, contains a list, as you can see here. And this list, engineer, consists of the first thing, the tag name. This bill of materials is a collection of materials that have been used in the drawing or have been used in our cell, including miniature circuit breakers, wires, terminal blocks, which are referred to as Rosetta. Any equipment or any simple component that has been used is included here. We call this the bill of what? Of material, as the bill of material is created. So here, this table first writes the name of this item in your cells, what its tag name is, whether it's called B1, B2, B3, or whatever it may be, it has a set of names. Then it includes my description, for example, what B1 consists of. B1 is an MCB, which is a miniature circuit breaker, 2B, which is two-pole, for example, 6 ampere trip, 63 ampere frame, 10 kilo ampere, 440 VDC, whatever curve C. Here, this is a complete description that details the technical specifications of your equipment. All right, and then it tells you the function it is used for. It says, well, it is used in the control circuit. Who is the manufacturer? It tells you GE, the company GE, General Electric. What is its type? Here is its type. Where is its catalog number? Here it is. Where is its origin from? It comes from Poland. Okay, its subcode, its number, the subcode, I have something here, and the quantity used in your drawing is 1. What did I benefit from this? Well, I benefited because I am a maintenance person, and I came to do maintenance and found that my B1 is faulty, or I am a testing person and found it faulty. I am a maintenance person, or I am doing maintenance. I took this equipment and tested it and found it faulty. I want to replace it. So you replace it with the same type. So you take the description and go to see the types available in your store. Whether there is a similar one or not, that's number 1. Okay, if there isn't, you will go to GE and tell them, well, I need, but don't tell them I need B1. You will tell them I need the MCB, which is of type 673322. Here it is 673322. Here it is 673322. Like this. And it is available for you in the subcode number such and such. And they give you like, okay, they don't have it to stop its production. It's not available with them. What will you do? Will you go to another factory? This time you won't use the data on the right. You will use the data over there to tell me that the second one is made. I want it to be 2 balls. 6 amps, trip, 63 amps, frame, 10 kiloamperes, 140 volts, dechi, or sorry, not 10 kiloamperes, 100 amps. Oh, regardless, I don't know how to read it well, but it is approximately 10 kiloamperes, 400 volts, dechi curve C. Oh, so now you have given him all the technical details on the basis of which he will give you the verse, he will give you this MC. So the bill of materials, you need to know what components were used in your circuits. Of course, as a person, you don't need to check the bill of materials every month unless you have a faulty component and want to replace it with another component, or if you're conducting tests. and have a problem and want to replace it with equipment. Next, we come to something called the page layout. Yes, this layout or the panel layout describes, as you can see, the shape of the cell, which is from the front. Of course, this is what we mentioned. And here is the place where it is. And here is the place where it is. And here. It's the back view. And here, what is the view, the side view of the house? All right. So I brought you pictures from the switchgear panel that I have at the Institute of Electrical Engineering. So you can see it. Here is the real front view panel of the switchgear. The top part is the low voltage compartment, of course, where the protection relay is located. Internally, I will also show you pictures of it. Internally, it contains control circuits and protection circuits. It includes a set of indicators, such as your ammeter, which is a mechanical device, and so on. And you have the middle part here, which is the section containing the circuit breaker. So we call it the circuit breaker compartment, which is the circuit breaker room. And you have the lower part, which contains the voltage transformer compartment. The cell from the side looks like this, and of course, here is the bus bar, as you can see. Here it is inside. You see this copper part that is visible because this opening is where the other cells will be installed next to it, and the bus bars will be connected here together. The yellow part you have here is the cable termination, or the part where cables are connected in addition to all. Right, very good. Of course, I brought you the part of the machine. It obviously saw this boost bar section where the cables will be installed. Here you have one, and here is the second and third one next to it. I didn't show you all of them. You might ask what's inside, so we don't forget. That's a capacitor voltage divider, which I will explain later. I will explain it to them later. All right, when the time comes, so I don't give you such information prematurely. Here is the current transformer. This is the output of the circuit breaker connected here to the current transformer before it goes down to our cables. These are real images for you. And I will show you a video I recorded for you of all these components related to our switchgear. All right. Then you have something called the low voltage door. Let's forget about the low voltage compartment. The part above is the low voltage compartment. It's a door you will open and find many things inside, right? It illustrates it for you, saying, here's your door with a set of lights above, a protection relay, and many things you won't understand until we study the drawing. Inside, when you open it, you'll find something in front of you here, something on the left, something on the right, and something below here. So what is this in reality? Here it is. As you can see, here's your door, engineer. This is your door, and when you open it, there's a side here on the right, a side here on the left, a side right in front of you, and a side below in this spot. All right, if I come to the spot directly in front of you, this is a set of terminal blocks. These are called terminal blocks. Let me show you here. Yes, text, so that you know, for your information, this is called a terminal block, or more commonly referred to as a rosetta in the industry. Just a moment. Rosetta, all right, that's what they call it in colloquial language. All right, for those who speak Arabic, they will find it called a rosetta. All right, engineers, very good. Okay, on the right here, this is the view of the circuit breaker, and also with it, a set of terminal blocks. On the left, you will also find a miniature circuit breaker, a thermostat, a heater, and here, a set of resistors. We will understand this when we study the drawing itself. Here's the back of your panel. This was the protection relay, and here you had the ammeter, a set of accessories, and here are your switches. Exactly, engineers, great. Now, when you are inside the drawing, all of this is in the first pages of the drawing, which describes everything for you before you delve into the drawing. Here, the attendees with us will know that I like to go back to something more than once, twice, or 3 times. What does that mean? It means you will understand from me when I enter the drawing, I will go back again and say to you, see this component? Let's go back with the material to see it. See this symbol. Let's go back here to the symbol, to its place, so we can see something called engine. This legend is a list of all the symbols that will be drawn inside your drawing. For example, you saw the view and wondered, what is this, engineer? I really don't know what this is. If you refer back to the symbols, it will tell you that this symbol takes the code named B, which means miniature circuit breaker. Now, if you see this view, it's called VT, which stands for voltage transformer. But if I see this view and don't understand the name of the switch, but if I see this view and don't understand it, it's called an ammeter. So there is always a page called the legend. This page contains all the symbols present in your drawing, and it comes with something called a letter code, a letter that describes your equipment, and it has a description of what your equipment is. Of course, it can be more than one page, depending on the number of components you have.